Students, today we will discuss the resonance. Resonance is a phenomena in which two or more structures can be written for a compound. It means a compound may have it may have two or more structures. Compound may have two or more structures. Right? These structures have identical position of atoms. These structures, they have identical position of atoms. Identical position, right? But these structures are only different to each other due to the arrangement of electrons, right? So these structures, they have identical position of atoms, but they are different to each other. These structures are different to each other due to the difference in the arrangement of electrons. Difference in the arrangement of electrons. Arrangement of electrons. Now students, it means resonance involve the delocalization of pi electrons. It means resonance involve delocalization of pi electrons. Now there are 5 resonating structure of benzene. If we talk about the benzene has 5 resonating structures. Now we'll see what are the 5 resonating structures of benzene. These are this is the first structure of benzene. First resonating structure. Resonance is represented by double-headed arrow. The second structure of benzene. Second resonating structure of benzene. Like this. Now numbering 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are 5 resonating structures of benzene. These are one. Resonance is represented by double-headed arrow, right? This is the first resonating structure, and this is the second resonating structure. Position of number of carbon atoms 1, 2, 3, 4, 5, 6. Likewise here 1, 2, 3, 4, 5, 6. Then the third resonating structure. The third resonating structure is like this. One, 2, 3, 4, 5, 6. This is structure A, this is B, this is C. Then the next resonating structure. Structure number D. Position of carbon atoms 1, 2, 3, 4, 5, 6. Then this is structure number D, and the next resonating structure numbering of carbon 1, 2, 3, 4, 5, 6. This is structure number E. So it means there are 5 resonating structure of benzene, and the resonance is represented by the double-headed arrow. These are the resonance structures, or we can say these are the canonical forms. These are the canonical forms. Canonical forms or resonance structures. The actual structure of benzene is the resonance hybrid of all these 5 structures, that is A to E. The actual structure of benzene is the resonance hybrid of all these 5 structures, that is these canonical forms. So actual structure of benzene is a resonance hybrid. Resonance hybrid of all these canonical forms, that is A to E. Now here the first 2 structures, these are given by Kekulé. That's why the first 2 structures, they are known as Kekulé structure. Kekulé's structures. And the next 3 structures, that is structure C, D and E, these structures are given by another scientist, that is de Waals. That's why these structures are known as de Waals structures. De Waals structures. The actual structure of benzene is the resonance hybrid of all these 5 structures, which are known as the canonical forms. Stability of benzene increases with increase in the number of resonance structures. Greater the number of resonance structure, greater will be the stability of benzene. Resonance structures are not the actual structures. These resonance structures or the canonical forms, these resonance structures, they are not the actual structures. They are not the actual structure of benzene. Actual structures, right? But actually they are not existent and hypothetical structure. Resonance structures are non-existent and hypothetical structure. These are non-existent and hypothetical structure. Now the first 2 structures are given by Kekulé, that's why they are known as Kekulé structure, right? And the next 3 structures, that is C, D and E, these structures are given by de Waals, that's why they are known as de Waals structures. In the de Waals structures, we can notice here the carbon atoms which are present at the opposite sides, right? That is carbon number 1 and carbon number 4 in structure number C, right? And carbon number 2 and carbon number 5 in structure number D, while carbon number 3 and carbon number 6 in structure number E. They are present at the larger distance as compared to the carbon atoms which are present adjacent to each other, right? So in the structure number C, carbon number 1 and carbon number 4, they are present at the larger distance. Similarly, in structure number D, carbon number 2 and carbon number 5, it is also present. These carbons are also present at the larger distance. Similarly, in structure number E, carbon number 3 and carbon number 6, they are also present at the larger distance, right, as compared to the carbon atoms which are present at distance to each other. What carbon are present at distance to each other? That is carbon number 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, and 6 and 1, right? So at distant carbon are 1 and 2, 1 and 2, right, 2 and 3, 3 and 4, 4 and 5, and 5 and 6. These carbon atoms, they are present at distance to each other. Now students, the Kekule structures, that is structure A and B, these structures, they have major contribution towards the actual structure of benzene. It means Kekule structures are major contributor, right, while Dewars structures, that is structure D, C, D and E, these structures are given by Dewars. That's why they are Dewars structures. Dewars structures, they are minor contributor. They are minor contributor. Minor contributor. It means they have minor contribution towards the actual structure of benzene, right? So that's why usually benzene is represented by Kekule structure. So benzene is represented by Kekule structure. Kekule's structures. I hope it is clear to you, students.